Hi there. I'm just putting this up as almost in answer really to this very good video from Creesoft, which was on the Discord server for Postshot, and it's basically explaining how to use masks from reality capture and basically use those to crop out the images so that Postshot is not processing background stuff. So if you're looking for an isolated object, or actually even with landscape things, you know, aerial shots, it's still really useful if you've got an extreme limit where you don't want to have any other detail. I haven't actually tried it in reality capture, but I understood the process, and I'm really pleased to say that Metashape, I think recently, has added the ability to do the same. It may have been all the time there and I just didn't notice that it was there. It probably is the case. But anyway, the idea of this video is just to give a bit of a walkthrough of how I'm doing the same process but using Metashape, which is... I prefer Metashape. I mean, I've used it for years. I think reality capture is fantastic, and, you know, for free. I mean, who cares? It is brilliant. But Metashape, I do find, works for me better. I do get better quality resolves, and I'm used to using it, and it seems a bit more logically laid out. It's quicker to use. I only have the light version of it, which does have some restrictions, unfortunately, which I'm a bit niggled by, because there are a few things which I think it should have, like targets and being able to set scale markers and things like that. It should really, in my opinion, be part of the basic workflow. But anyway, that's another story. So I basically wanted to start from a blank project, and I've just selected a really basic data set. How many is that? However many images is that? Not very many, and the reason being because it's quick to process, so we can talk through it. The subject is actually a sundial from the 1700s of an old church in West Cornwall, which is where I live. There's a really lovely little sundial on this church. 1720, there we go. Okay, so obviously the first thing to do is align them. I always go highest. Why would you go with anything less? This is to do with how it orders the photographs. Like if they're sequentially overlapping and it's obvious, then use that. If not, use the estimated works, whichever way you do it anyway. So that's fine. We've got a fixed camera, so we don't need to use adaptive camera. And I just tend to leave the default settings, so pretty much default for everything, and as initial run, and that seems to almost always work really well for me, and it's quite quick. So that's great, and that immediately gives us a solve. Let's have a look, with about 32 pixels projection error maximum. So, you know, okay, good, we could run with that. It would work fine, I'm sure. It wouldn't be too much of a problem, but we can reduce that down quite easily using the gradual selection tool. Actually, let's just zoom in on this a bit. Nice to just set a view where you can just overall see what you're getting rid of as you go through, but gradual selection, and then we're just going to work our way through these different options. The reprojection error, I try and get it down below 1, and by the way, I'm not an expert, by the way. I'm just this is just my workflow, so, you know, I'm sure if you've got any tips and things that would improve this workflow, please mention them, because, you know, I'm just giving out how I work with it. So you can see as you put the slider up, it's selecting more and more. So everything below that threshold or above that threshold is being selected. So, I mean, you could go extreme, but we're obviously, you know, under 1. It seems to be pretty good, unless you're seeing anything obvious there that you need to get rid of. Whilst that is open, just press delete, and that gets rid of those points. Reconstruction uncertainty. Again, this is really just by feel. It's not. I don't want to be getting rid of too many. You see how the sundial, the actual dial of the sun shadow pin thing, is highlighting. I don't really want to get rid of those, so I'm just going to come back a little. And that seems pretty good. Press delete, get rid of those. projection accuracy. Now obviously we want to just be using the really accurate projections, so without destroying everything. So let's give that a go, and if we look now at the information for that data set, we're getting down to a pretty good, look, there we go, sort of 4 pixels maximum projection error. So that's great, and you know, if you're really doing an important data set, then obviously you'd work a lot harder on that than I'm suggesting now. But what that's done is that's just pruned out the bad points. So we still need to retrain the camera, retrain the software to look at those better points and use that for its camera solve. So what we're going to do is go to the tools, and we want to go optimize cameras, and in here you can select the level of lens and camera itself corrections. Now there is a bit of a debate about this at the minute, and part of the reason of this workflow talk as I'm going through is to discuss precisely this. When importing into Postshot, if using the COLMAP format can't actually solve anything above the default ones that are selected here. So even if you do correct here, you're not going to get the result of that if you export your original images. So yeah, I'm not explaining this very well, but you can get a better camera solve if you put these on. These last ones I've looked up, and they're really, you know, that's touch and go whether you need to actually select those, because they're really about the alignment of the camera plane, the actual sensor plane, and things like that, which could potentially, you know, cause more issues because it's trying to work out too many calculations, which could throw off other calculations. So it's arguable whether it's advantageous or not. But for demonstration purposes, I'm going to use all of them. And the reason I'm using all of them is because part of this is when we export the COLMAP format from here, it doesn't really matter what I use. If we don't transform to Pinhole camera mode, which what that does, thanks to the explanation of a few people on the various forums, thank you, what it does is it does the undistortion of the image within Metashape. So Metashape will take all of those camera lens correction parameters that we've told it to resolve, and it will undistort the image according to those camera parameters. Whereas and then transforming to Pinhole means that it exports a zero correction requirement camera set. So basically the images are already distorted. Postshot doesn't need to do any post-processing, and it will just take the image as a correct image and correct camera, so absolute camera positions. If it's not selected, then what Metashape will do will export the original images, and it will give a set of camera lens error instructions to Postshot for Postshot to try and resolve. So Postshot has to do the processing of the images, the undistortion of the images, which, using the COLMAP format, if we just select OK now, you can see this warning here. It's, you know, selected format doesn't support all camera parameters. Calibration parameters. Some data will be lost. So what that's saying is that basically the COLMAP format can't work with those higher level camera solve corrections that we've done within Metashape. So it really is advantageous to, in my opinion, to do those extra corrections and then use a Pinhole transform to make Metashape do all the work to get the good undistorted images out, making use of those extra parameters. Sorry, that was a very long-winded way of saying it. But in this process, we also need, if we want to mask this off, we actually have to make a mesh, which we use as the mask. So rather annoyingly, you can't just set the region, so resize the region. You can't just use this as the mask, unfortunately. I'm not quite sure why, because it seems fairly logical to me that it would be able to do that. But anyway, you can't. So we have to do this, make this mesh basically to use it as a mask. But first of all, I'm just going to align this to something reasonable. So using the number pad, the keypad, if we go to toggle between 5, it gives us orthographic view, and 1 will give us front view. So automatically we're now looking at what, this is a sundial on a vertical plane, so we want it to be from the front view, vertically aligned. So we want to rotate the object, and this is a very laborious iterative process, so please excuse me. Oh, it's upside down. I do find this frustrating, but orthographic view is very helpful in my opinion, because you know that you're looking front on. You can use, for example, this bottom edge here if you want to make that your oh damn it, I don't know how I did that. If you can use that as a straight edge. And actually there is a request for Metashape to put a grid in there, so it's actually a bit easier again. But switching between top view and front view and side view, we can just do an iterative process of trying to align this to a standard view point, which we can do later, but it's very helpful to get it done in here. I find I just start with the data that you want to be using, but it is a bit boring, so sorry about this, bear with me. Interestingly, in Cloud Compare, there's a very, very useful tool which is aligned to 3 points. So you could basically click 3 points, and that would align to a plane, as it were, which would save a lot of time. But anyway, right, that's good enough for what we're doing. Oh, I wish I hadn't done that. Okay, let's try and get that back again. Okay, that'll do. Right. Also, does anybody know? I don't know. Please leave the answer in the messages. If I move this, right click and drag it around now, is that determining the central point of the datum point? I don't know, because it's not clear in Metashape. So if someone knows the answer to that, there is no real way of seeing what the datum point is in Metashape. I've actually asked for it years ago, and they didn't know what the hell I was talking about. But anyway, right. So there's a few things we need to do. We need to rotate this region because it's skewy and not very helpful, and resize it. And what this is going to do is just basically, this is our work area, so we're only interested in the sundial, so we only need something just around that basically. And here is the actual shadow point pin, so we don't want to clip that off. We do want to, however, make sure there's nothing behind, because what we're going to create in a minute is the mesh mask, and that is what determines the mask for the images. So the next stage is to create the model, and we actually really don't need a high quality, because this is just literally a mask. If you go too low, you'll end up with something that's so chunkily pixelated that you'll get some really rubbishy masks. The edges, particularly the edges of the mask, end up being quite, you can see the polygon count in them. So something reasonable, medium, is pretty good, I'm finding. And we don't need the vertex colors. That's just a waste of time for us, because all we need is the mesh just to use as a mask. So that should be fairly quick to run through. Yeah, again, the reason why I chose just a few photographs was just to try and make the actual processing quite quick. And come on, there we go. Right, so now we have the mesh, which is great, which is reasonable anyway. See, this is what I was saying on the edges here. If you go too low, if you look across here, you'll see that the edges kind of tend to get made up a little bit. They don't actually make real sense. They're not very good edges, but again, for demonstration purposes and for time, it's just a low mesh is absolutely fine. And what I'm also going to do is build the point cloud, which we don't strictly need to do, but I'm going to show the difference between making a decent, exporting a decent point cloud and exporting just the tie points and the basic alignment points. So we're going to use depth maps. Medium is fine. We don't really need super high quality, and again, just to save time. And we do want the point colors. Now, again, there's a bit of a discussion on this. In my experience, I mean, you can just use white, and that leaves it up to Postshot to, well, Postshot is always doing the color processing, but if you go with white, it actually starts with a white splat and it has to add the color in bit by bit, which in my opinion takes longer because it has to solve the color issue if you're using a white point cloud. Whereas if you give it color data in the first place, it's already got a good starting point, and I'm sure it helps with the alignment because it makes sense. I'm sure I'm just probably making that up now, but anyway, I find that using the color point cloud is actually a really important time saver, and accuracy is much better with colors. So do calculate the colors, in my opinion. Just do. It doesn't take very long. Calculate point confidence we don't need, but it is useful if you're exporting it to Cloud Compare, so it can just be a useful bit of data to be able to filter out dodgy points and things if at a later point. Okay, so now we've got our mesh, we have our dense point cloud, which should be coloured, and which is all right, a bit missing on here. If we'd gone a bit denser, we may well have picked up a few more points in here. And actually, you know, if I hadn't been so sort of harsh with the slider for the gradual selection, we may well have seen a few more points in there. But we don't really need that for Postshot, because even though it will be a bit more cloudy in this area in terms of the splats, it will take longer for it to work it out. It will work it out eventually. But obviously, the better the output you can get in the first place, the quicker and the more solid the final splat, and the quicker it resolves. And I'm going to show the difference between using a thin point cloud and a dense point cloud. So all we need to do now is just make the masks, which are obviously the subject of this tutorial. So from model means using the mesh model that we've just made. So interestingly, it has got an AI mask creator. I've only tried it once, and it did an okay job, but it was a bit hit and miss. And actually, you know, if we can just use this model where we've got complete control over it, and incidentally, you can actually go in and edit that mask, that mesh as well. Just delete bits, and that will contribute to the masking in the end. So if there's a bit that you really don't want in there, you can just delete it. You know, just use the tools, the select tools up here, and just, you know, get rid of the bits of the mesh you don't want, and that will effectively make the mask. So from the model, this is just to do whether you've got masks already. Replacement is fine, all images, and it takes a flash of a second to do. It's very quick, and really that's pretty much it. Just a note and a side note, if you're using a very big data set, a really useful tool in here is reduce overlap, and what that'll do is go through all of these images, and it will just basically give you the optimum amount of images to work with, which is great if, you know, as we know, you know, too many images in Postshot in Gaussian splatting is actually undesirable. You get a sort of cleaner result, more reliable result if you use well spaced and kind of fairly sparse cameras, as long as there is overlapping areas in them. But for aligning a point cloud, for doing the original camera solve, obviously you want more images. So once you've done the alignment, you can then use that tool to get rid of some of the images, which will reduce your data set. Sorry, I just hit the mic. Anyway, that's just an aside. So we've got the mask, we've got everything we need now. So basically, we're just going to export everything as COLMAP format, and we're just going to call it sundial. Doesn't matter what you call it. Now here we are, back to this. We want the images, And because we're using transform to pinhole camera, and this is the important bit, what that's going to do is underdistort the images according to those camera corrections and optimizations that we did within Metashape, which are above and beyond what Postshot can do. So yes, transform to pinhole camera, and in my tests, if you export one without, one with, I found that the one with transform to pinhole camera is a better resultant splat. So that is preferable, purely because Metashape's doing a higher level camera solve. So that's the principle behind that. The masks you definitely want, because we're going to be using those. I don't understand what the transform to initial calibration is. If someone can explain that to me, that would be great. Thank you. And binary encoding, it seems to be more reliable with Postshot, I have found. And anyway, it does work with both, but I've just found binary encoding seems to be more reliable. So that will take a little bit of time, because it's got to basically underdistort all of those images. But we should start seeing the images appearing now, which, if we compare the size, that's 3998 by something or other, and the original images are 4032, and that is because in the underdistort process it needs to crop in, otherwise you're going to have black, curved black edges to compensate for the lens correction, so it has to crop in to give you a full image. I mean, theoretically it could export alphas as that edge, which would work as well, but anyway, it does crop them. So it's important that we make sure that we export the correct undistorted images and use the correct undistorted masks as well. You can export the masks directly from within Metashape here, however those are only the original images, they don't have the image correction. So if you could save time and just export from here image with alpha channel, and if you change this to file, I think the default is something else, I can't remember, it says mask I think, but if you change it to file number, which is the same as the COLMAP export, you can literally just export these and swap out the original, or just use those images rather than use having to go through the process of combining the images and the masks. However, as I said, these are the original images, so you cannot, if you're going to use this process, which is quicker, you cannot use the option to, where was it? To transform to pinhole camera model, because that's you're going to get a mismatch of images. The images won't be correct. The exported mask images will not match with the camera solve. It probably doesn't make sense. I hope it does. It does to me. But okay, so I'm also, while I'm in here, because I said about this needing the better quality of the high density point cloud, is I'm going to export that as well, and I'm just going to call it high. And we do want the colors. Again, the colors are important. Binary, do we need, I don't know about the 8-bit thing. Okay, the reason why I've imported that is because if we open that in Cloud Compare, and if you haven't used Cloud Compare, do, it's fantastic for all things point cloud. It's a really amazing toolkit, and it is funded, I think EU funded, but they do need money, so you can donate to them, and I would, if you can afford to do it, because it's such a good program, and they do listen to you, they answer questions, and it's a really good bit of software. Now, this is quite a dense point cloud, which is not too bad actually, that one, but the reason I've brought it in here is because we want to just thin it out a bit more, and I tend to use in here, sorry I'm rushing past a bit, if we go to yeah, it's actually the shortcuts here, it's subsample a point cloud, so select the point cloud, use this subsample, and I would recommend using Octree method. There are different methods of thinning out the point cloud, but with Octree you get a uniform point cloud, so you don't have random scatters, which may be good, may be desirable. It's worth testing to see what the differences are. But actually, Octree, and I tend to set it around 9, what that does is gives a very uniform point cloud. I'll turn up the size of the points there, which I find tends to work. Postshot really likes that. It seems to prefer that to a random scatter, because it's a dense cloud, but it's very evenly spaced. It's like a canvas for it to focus on. So I'm going to save that as low. And unfortunately, there is a bit of binary is what you want to save it there as, by the way. There's a bit of messing around further to get that into the COLMAP format, and I've used the COLMAP GUI, Windows GUI. Obviously, if you can use the command line version, then do, if that's your preferred method. But we want to bring in this low, the reduce down count one, and don't alter its date and point, because obviously everything's according to the camera alignment. So we're only opening this in here just to basically export it as a COLMAP point cloud. So make a folder, that's where we're putting it. Thank you very much. Thank you, COLMAP. And now we should have, you see we have this .3D bin, which is 13.8 kilobytes. Oh, actually, before I swap those out, this is the one that's exported from Metashape. There's 1,000 kilobytes, but I'm going to save this because I want to show the difference between the two later. But let's just pop it in there, and then grab the COLMAP exported one, so the more dense point cloud, and we're going to replace this one, which is the lower one. So paste it onto there, replace it, and you can see we've just bumped up that initial point cloud, which is great. And then there's one more stage we have to do. We have the images and we have the masks like this, and this mask is based on that mesh that we had in Metashape from the point of view of each camera. So it's great, but unfortunately at the minute Postshot can't just pull both of those folders in, which would be awesome if it could do that, because it would save a lot of time. So we have to basically use a little script to combine them manually. And in this thread there was a lot of discussion about little scripts to do that, and I think it was this one that I used, or anyway, one of these. If you go to this thread, creating and using masks in Postshot, there's people have very kindly put up a few different scripts, little Python scripts, which does this little combination work for you. I'm not, I don't do much scripting, so I'm not that hot on it, but you do need a couple of dependencies. So I can't remember, it's CV, and I can't remember what that stands for. It's one of the image manipulators scripts for libraries for Python to do image manipulation. So you need a couple of those. What I did was take one of those codes, and I can't remember which one it was, but thank you, and just use ChatGTP to just make it into a GUI, because I hate having to remember and type out command lines. It really does my head in. So anyway, look, so this is a little GUI. I will put a link to it, so help yourself, do what you want with it. I didn't make it. It was ChatGTP did it for me. So anyway, look, browse for your image folder, that one, your masks folder, and your output folder, so where you want them to be after you've after it's done the magic. So that's it, and PNG is what I want to use. Run the script, just with these few images it shouldn't take very long. Thank you very much everyone that contributed to that, and AI and whoever originally came up with the idea of Python, and everyone that needs to be thanked for it because it's great. So now we have the original images with masks applied. So there's no data outside of that. I think it's an alpha mask. I haven't actually opened them up to see whether it is just a masked out image or whether it's actually deleted the pixels in there and left an alpha. You know, I don't know which way around it is, but that is all the data that Postshot is going to get. So there's no pixels outside that are going to cause floaters or anything else. And that's it. So then we're ready to go with Postshot. And we're going to use the output images, the masked ones, the combined masked ones, and the sparse cloud. But the sparse cloud is actually the high density or reasonably high density point cloud. I tend to use ADC. Big discussion, not getting into it. We don't need to use the treat alpha as mask. That is a bit of a confusing thing. We are using alpha masked images, but we, from the way I understand it, very kindly explained, the idea of selecting that is when you want to mask out individual things that shouldn't be in the image, so like someone was walking past or something like that. So you can go to those individual images and mask out those people using an alpha mask, and that's when you would select this. But Postshot will recognize that these images have alpha masks and it will respect them, and there will be no data there. So you don't want to select that, even though we are using alpha masks. I hope that's clear, because it isn't clear. We also don't need to select create sky model. That is a really useful tool, even though the sky model is, sorry Yashka, is awful. It does actually detract some of the from some of the floaters that you get, so that's quite useful. But in this instance it actually makes things worse, because we have no data outside of the masks. If you put that on, it's more likely to create splats, because it's floaters, because it's trying to create a sky model out of effectively nothing, or the only data it's got is the actual bits of model that we have to make a model from. So anyway, I'm rambling about that, but just don't select it. And I'm not going to start training instantly, because I want to look at the point cloud here. So this is the point cloud, the denser one that we made, that we basically exported and then thinned out in Cloud Compare. And I just really wanted to show that, because when you run with that, you get an instantly bang on kind of splat. Like it takes seconds and it's almost there, because of the denser splats and because of the colour. I mean, while I'm here, might as well just do this for fun. No, I'm not going to do it. I was going to say you could make those splats white and it will work, but you will see that the initial splats come out white and then they gradually start developing, which is fine, but it's having to do more processing. So it's just slowing the whole process down, because you're making Postshot do more color correction than it actually needs to do. And the same with the point cloud, because the reason why I wanted to, let's just leave that training. The reason why I wanted to, if I open up another instance, the reason I wanted to show the difference between the two is if I go back in and replace the higher one that we just put in there with the original one, much lower density one, you can see ADC. So this is what would have been exported directly from Metashape, which is fine and it works, there's no problem with it, but it's considerably less dense, and therefore when you go to run the training, it takes a lot longer. Obviously the algorithm for solving the splats has to work a lot harder to find those extra points. So even though it works, and it will resolve into a very nice clean splat, just like the other version, but you can see instantly that it just takes a lot longer, and it's having to do more work. So why would you know, if you have the ability to export something, it takes maybe an extra minute or two to export the higher density point cloud. So it is a bit of faffing around, and I wish that Metashape would add that as an ability to export, because I did request it, but I can see their argument. They're saying, okay, well, if there is an actual format, a correct format for COLMAP format, so changing out the point cloud for a high density one isn't the correct format. So yeah, fair enough, but it could be an option that could be just added so that you could do it if you want to or not, you know. But anyway, in my opinion, you get a better result using a more dense point cloud. I mean, let's just stop this after 2,000 steps. Oh, we've already gone past it on the other one, haven't we? Sorry, I should have stopped that one. Oh look, there we go, 2039. So 0.852 SSIM. Oh, I'm probably opening the wrong one. Oh yeah. Come on, nearly there. Oh, why didn't it stop? Okay, maybe I've just got my maths wrong. Okay, well anyway, look, 2.054, and the SSIM is 793, whereas in the other one, 2,000, slightly less iterations, I think. Anyway, 0.852, so better resolution, quicker. So, you know, if you've got a big data set, that could be quite a big time saver, actually. And you know, what you're going to find is, because the point cloud in this is so much more sparse, there is no data in here at all, whereas if you look at the dense one, you know, we have got some data in there. So instantly the splatting process isn't having, it will have to make them up in this area here. So that initially that area will be probably a little bit fluffier because it's making it up, and it, you know, so basically there's less information in there for it to work with. So but if you compare that to one where there's virtually no data at all, you know, although it looks sort of clean because it's masked and everything, there's a lot less information going on in this than there is in this, and purely because of the density of that point cloud. So I know there's been a lot of discussion about, is the point cloud important, but in my opinion, yeah, it is. I mean, it depends which way you want to look at it, doesn't it? Because if you don't have it, it will still work as long as there's enough points there for it to just start cracking on with it. It will work, but it's just taking a lot longer, and where you have missing information, you're just going to get, you know, it's just going to take a lot longer to solve that, which means that you're going to have an uneven splat, because where you've got a very, and this is what I was saying about the evenness of the point cloud, where you've got an even point cloud, you've already got a canvas. It's already given it a equal density to the point, to the splat, if you see what I mean. So you're going to get a more even and consistent result with a nice even dense point cloud. It's just, as far as I'm concerned, I think that's pretty conclusive, really. So you can see here, you know, there was more data around here, but see how it's a little blotchy in areas, because the point cloud was a little blotchy in areas, and that's precisely the correlation. So if you want a more even splat, so more evenly distributed splat, then I think that's the way to do it. I mean, if we look at the, how do we go? Oh, it's viewport camera, isn't it? Right, if we go to grayscale. I actually haven't tested this, so this is an interesting experiment. Oh, actually, that's actually looking quite dense, isn't it? But anyway, you get my point. It's having to make up the splats rather than already kind of having the information there for it. So interesting. Anyway, that's pretty much it, really. I hope that was helpful. And like I say, you can, if you don't want all that hassle, the quickest way to do this really is to export cameras, and don't do transform to pinhole camera. Don't export the masks. In fact, don't export the images. This is the quickest way, basically. But you do want the points. Oh god, we're going to write over everything, aren't we? But anyway, okay, let's see if this works. But then export the masks themselves from within Metashape, image with alpha channel. So it does that work for us. That bit that we did with the Python script, this is done for us. Just the only thing is to change this bit here to file number, so that it respects the same notation. What are we going to call this? Masks or something? No. Yeah, okay. So I've probably just overwritten those. Yeah, okay, anyway, there we go. So that's it, actually. That's all you have to do. This is the very quickest way to do it. So if we start a new Postshot, we should have everything we need, basically. So now if it's finished, yeah. We've got the very base sparse cloud. We didn't bother outputting the images, but we have exported we've told it to use the distortion correction information, but we have got the masks which are now done for us by Metashape. So that's the quickest way to do it. If you're really not that bothered about kind of top quality, then just go do it that way. Masks, sparse, that's right. Postshot, and that's it. So that's definitely the quickest way, but the quality won't be as good. I mean, it'll be good, but it's just not quite as I found the camera alignment, with those extra parameters is better. So if it's a really critical data set, then I would use the process I'm using. But if you just want to bang something out quickly, then it couldn't be quicker than that. We've just done it in a few seconds. So there we go. I hope that's helpful, and cheers for now. Bye.